Hello students and welcome back to my channel. In today's video, we'll be discussing about the intensity distribution in interference of light. Okay, so let us start. Now you see students, basically we have a source S1 here, light source, and the source S2. Okay, in interference it is necessary that the sources emit waves of constant phase difference. Either the phase difference must be zero between them or it should be constant with time. And second most important thing is that their frequencies must be same. Okay. When waves superimpose with equal frequencies, then such kind of superposition is specifically termed as interference of light. So interference means superposition of two or more waves, of course, two or more waves having same frequency, having same frequency. Okay, right. So now we want to analyze the intensity at a point on the screen somewhere here. You can see this is the screen here. Okay. Now since f is same, so 2 pi f is also same, isn't it? So 2 pi f is also same. So therefore what we can write is omega is also same because omega is equal to 2 pi f. So both have same omegas. Now due to this wave, that is wave coming from source S1, the displacement at point P be taken as, let us say, y1 is equal to a1 sine omega t. Remember students, light waves are basically sinusoidal waves, and in fact here we are basically discussing or taking into consideration only the electric field. So electric field oscillates sinusoidally. So this could be the equation here. Similarly, the light wave coming from source S2, as soon as it reaches here, there will be a phase difference between the first and the second waves. Because as you can see, the length S1p is not equal to length S2p. So length S2p clearly is greater than S1p. Here, as per the figure I am telling, it can be equal also, but in the figure it is not equal. So basically, in such a case, what will happen? That there will be a phase difference between them. So that difference could be plus or minus delta. Okay, that depends on the what you call difference between the path length and which is greater and which is smaller. One serious point you have to understand that if S2p is greater than S1p, then delta will be negative. So you have to take omega t minus delta t as shown in the figure. Whereas if S2p is less than S1p, then you have to take delta equal to positive. Clear? Anyway, so here as we'll see that it hardly matters whether delta is positive or negative, because ultimately we'll be making use of the expression which involves the square of cos. Okay, so not a problem at all. So these are the two waves which are interfering at this point, or they are getting superposed simultaneously. Now the resultant wave can be expressed by the law of principle of superposition. So according to the principle of superposition, the resultant wave of two or more waves are basically the vector sum. In fact, principle of superposition simply implies the vector addition. That is, when two or more quantities can be added vectorially to get the resultant, then we say it is obeying the principle of superposition. Now here the particle P is same, and there is no question that it can oscillate in any other way. So you can simply remove the arrows. For the same particle, this displacement has to be same. And second thing, we'll take into consideration all the phase difference between y1 and y2, because basically when we consider the phase difference between y1 and y2, we are actually adding them vectorially, right? So we'll have a shortcut here. So straight away we'll add them vectorially. So let us see how to add. You see, the first equation has a1 as the amplitude, and phase is how much? See, phase is omega t. The angle containing the sign. The sign contains the angle. That angle is known as phase. For the second wave, a2 is the amplitude and omega t plus or minus delta is the phase. So therefore, what I can write is like this. Suppose you have a vector like this, whose amplitude is a1, and you have another vector whose amplitude is a2. If delta is positive, then this will be the figure. if delta is positive. So this angle of deviation of A2 from A1 should be delta, the phase difference between them, as you can see. We have taken delta as the phase difference. If delta is positive, assuming delta is positive, I have taken. If delta is negative, then you have to take in this direction. Then, so the resultant wave as per law of vector addition will be this, isn't it? Yes. So this is the resultant wave. Okay. Now from law of vector addition, we already know that a square is equal to a1 square plus 2a1 a2 cos delta plus a2 square. So this is the formula we all know from law of vectors. Is it? Also, if this angle is, let us say, some angle phi, then I can write tan phi is, from here you can see, perpendicular upon base. So this length will be, sorry. So this length will be a2 sin delta, a2 sin delta, and this entire length will be a1 plus a2 cos delta. And this you have already studied, students, in the class 11 physics portion, that is the first chapter, basic mathematics, right? So now, with the help of these two, what I have written, sorry, with the help of these two, it is enough that we know these two things. Okay, so this is one equation and the other equation is this, right? Now you can find the resultant amplitude this way by taking square root of this. So resultant amplitude will be this. Okay. Then now we know that the intensity is proportional to square of amplitude and square of frequency. This is true for any wave, students, including the electromagnetic wave. Remember, light is an electromagnetic wave. But f is constant for both, and also the resulting wave will have the same frequency as that of the individual waves. So you don't have to consider the variation of frequency. So you can simply say intensity is proportional to square of amplitude, and let us take the proportionality constant as some k, where k is some constant. Okay. So if we multiply equation 1, I'll number this as equation 1. If we multiply equation 1 with k, then multiplying equation 1 with k, we get, you can see here, ka square, etc., etc. So we'll be getting ka square is equal to ka1 square plus, here I'm writing k as root k into root k, root k into root k, and ka2 square. Okay. So this will be the resultant intensity. This will be the intensity due to the first wave. This will be, sorry, here I missed two students, sorry. So this will be square root of intensity of the first and intensity of the second multiplied by cos delta plus I2. Okay. This is the second equation. So you have to memorize this formula, students. Okay. Right. Then let us calculate of the calculation of maximum and minimum amplitude. As you know, when two vectors are added, remember, amplitudes are, they get added vectorially. So maximum amplitude can be obtained by simply adding them, is it? And minimum amplitude can be obtained by taking the difference between them. Taking the difference means from the larger value you will be deducting the smaller value. From the larger value you will be deducting the smaller value. So this way you get this. So sum is the maximum value, difference is the minimum value. Now similarly, intensity. Now intensity being k into a square. So if you are interested in the maximum intensity, then it will be k into maximum amplitude square, and maximum amplitude is this. So we can write this as k into a1 plus a2 whole square. Similarly, if you are interested in the minimum intensity, then you have to take into account the minimum amplitude, which will be k into, now you can write a1 minus a2, because even if a1 is less than a2 doesn't matter, because after all we have to square this expression, square this. So square will always be positive. Okay. Then secondly, in terms of I1, I2 also we can say. So here itself, as you can see, depending on the value of cos delta, I will be maximum or minimum. If cos delta is maximum, I will be maximum. If cos delta is minimum, I will be minimum. So from equation 2, for I max, we have to consider the maximum value of cos delta, which is I1 plus twice under root I1 I2 plus I2, because maximum value of cos delta will be how much? Plus 1. So if you write I1 as under root I1 whole square and I2 as under root I2 whole square, then you can straight away write this as root I1 plus root I2 whole square. Then similarly, for I to be minimum, cos delta should be minimum, and that minimum value is minus 1. So substituting that, we have minimum intensity as I1 minus 2 under root I1 I2 plus I2. Rewriting I1 as root I1 square and all, it is easy to see that it will be under root I1 minus I2 whole square. All these you are supposed to remember. Okay. So now let us take the ratios also. Here itself I'll take the ratio so that you understand properly. So here I can write the ratio of I max to I min, A max to A min is A1 plus A2 upon A1 minus A2. You have to take the mod here. Okay. Because if A1 is less than A2, A1 minus A2 will give a negative value. Amplitude is never negative. So always use the mod. Okay. Then similarly, if you want to know the maximum intensity and minimum intensity ratio, then just you have to square this. That is, it is the square of the ratio of corresponding amplitudes. So which will be equal to A1 plus A2 upon A1 minus A2 whole square. Okay. Similarly here, if you want to know the ratio of maximum to minimum intensities in terms of the intensities of the individual waves, then you can write this as under root I1 plus under root I2 whole divided by under root I1 minus under root I2 whole square. All these formulas are supposed to be memorized, students. Okay. Then next is a very common term is used, which is known as fringe visibility. Fringe visibility. Okay. It is denoted by eta or something. Now, or you can take it as V, capital V, not a problem. It is a measure of the contrast between the dark and bright fringes. If there is proper contrast between dark and bright fringes, we say the fringe visibility is good or better. Okay, so it is expressed in this way: the difference in maximum and minimum intensities whole divided by the sum of maximum and minimum intensities. So this is the okay. Now, if the ratio of intensities, let us say, is beta, let us say, then we can calculate this I max minus I min upon I max plus I min. How? See, fringe visibility is, now I max we studied, see here students, I max is under root I1 plus root I2 whole square, whereas I min is how much? Under root I1 minus under root I2 whole square. So this I can write here, from here, I max is under root I1 plus under root I2 whole square, and I min is under root I1 minus under root I2 whole square. Then whole divided by same thing here, under root I1 plus under root I2 whole square plus under root I1 minus under root I2 whole square. Now here if you use a plus b whole square formula, you have a square plus b square plus 2ab, whereas here you will be having a square plus b square minus 2ab. So a square plus b square will get cancelled, and here we will be left with what? 4ab. 4ab. Whereas here a square plus b whole square plus a minus b whole square will be twice a square plus b square. So I hope you are understanding, students. Straight away I have applied the formula. So 2 2s will cancel 2 here, and we can have 2 under root I1 I2 upon I1 plus I2. Okay. So we can express this in terms of I1 by I2. We can express in terms of I1 by I2. So in that case, we have to divide numerator and denominator by I2. Okay. If we denote numerator and denominator by I2, so here what will happen? Here I am taking I2 within the square root sign, so it will become I2 square. Whereas here, simply keep it as I2. In the denominator, simply keep it as I2. Not a problem. So now we see here one I1 gets cancelled. Sorry, I'm sorry. One I2 gets cancelled here. One I2 gets cancelled, and here also I2 gets cancelled. So we are left with what? See, twice under root I1 by I2 whole divided by I1 by I2 plus 1. But since I1 by I2 is given as beta, so we can finally write the fringe visibility as twice beta upon 1 plus beta, twice under root beta, isn't it? So this is the formula, twice root beta upon 1 plus beta. I hope that is clear. So now we'll consider a special case where A1 is equal to A2. A1 is equal to A2. So let us consider a special case here. So special case when A1 is equal to A2 is equal to, let us say, A naught. So obviously I1 will be equal to I2, which we can call it as I naught. Okay. So now students try to understand, if they have not specifically mentioned anywhere regarding the amplitudes or intensities, you have to assume them to be this case only. Okay. So instead of special case, it's more better to write it as a general case. Okay. Unless otherwise specified, we have to assume this condition only. Right? Okay. So here you see, if you have A naught here and another A naught here, both are inclined at an angle delta, then we know that the resultant will be in this direction. Resultant amplitude will be. So these angles are delta by 2, delta by 2. The component of A naught in this direction is A naught by 2, A naught cos delta by 2, and component of A naught is A naught sin delta by 2. Similarly, component of A naught in this direction will be A naught cos delta by 2, and in this direction will be A naught sin delta by 2. So this A naught cos delta by 2 will get added up. So resultant amplitude will be twice A naught cos delta by 2. These sin delta by 2 components will get cancelled up. Okay? They get cancelled. So this is the resultant. Now, squaring both sides and multiplying by k. Squaring both sides. Squaring both sides and multiplying by k. We get k a square will be 4 times k a naught square into cos square delta by 2. In other words, the resultant intensity is 4 times the intensity due to each slit multiplied by cos square delta by 2. Okay. Now, we have a simple formula, students. 2 cos square theta is 1 plus cos 2 theta. So using this formula, we can rewrite this as I is equal to, okay, I'll keep 1 2 there itself and I'll absorb 1 2 here. So 2 cos square delta by 2 will be 1 plus cos twice of delta by 2, which is delta. So this is also a formula. You can use any one formula, but this is more popular, this one. Now, one more thing we have to realize that here itself, let me tell you, the maximum value of intensity will be 4 times I naught when cos square delta by 2 will be maximum. Is it? When cos square delta by 2 is maximum, and the maximum value of cos square could be 1 plus 1. Similarly, minimum intensity will be 0 when the value of cos square delta by 2 will be 0, because the minimum value of any square, real number square, is 0. So there will be perfect contrast, you can see, because minimum intensity is 0. So there will be perfect contrast in the fringes amongst the different fringes, bright and dark fringes. So I hope that is clear, students. Is it clear? Right. So now what we'll do is that we will stop here. Right. Thank you.